I'm in Washington, D.C.
Oh, DC. I love the East Coast.
It's awesome here. It was so pretty landing and flying in. The trees are just on flame. They're just bright yellow, bright red.
That's cool.
It's
My son's flying into New York City right now.
Oh, it's so pretty. Yeah. Good for him.
Their marching band gets to march in Macy's parade. So if you see there's my son is marching with their marching band.
I'll be watching
Which
them. It's
band?
family tradition.
Davis High School.
What's it called?
Which one though?
It's the only marching band. It's Davis High School marching band.
Davis High? No way.
Yeah.
I used to do that.
You know Davis High?
I'd come down for the Mount Timp competition.
Oh, cool. Yeah.
And
Yep. I've had boys in there for like 7 or 8 years in their marching band.
So many.
It's cool.
Yeah, I did it, and we'd come down and compete at Mount Timp.
Oh, awesome.
And then we'd stay and watch Davis and American Fork.
Yeah. We always come in second to them. Cool. Yep, so they're marching in Macy's.
That's super cool.
It is. The last year our band director is retiring, and this is his last hurrah.
Hey, you guys, keep shopping at Macy's, even if online, because that store is really struggling.
Is it? Huh.
Oh my gosh, they sold so many other stores, and yeah, it's tough. They're having a hard time.
Yeah. So are we ready to get right into the quiz then?
I think so. Yeah. I'll hang up when we get too noisy, guys.
Okay. I'm excited that it lined up this way. We have a test and nothing else.
Yeah. Makes it so much better for Thanksgiving break.
I wish all the classes did that. I have assignments due on Thanksgiving Day. It's weird.
Yeah.
No respect for our forefathers or whatever, whoever we're celebrating.
My easiest campus class all of a sudden had 3 assignments that we're supposed to do over this break.
Oh, dear.
Gosh, sorry.
So I just got the test or the homework open. You ready?
Yeah.
I should pull mine up too.
We're on number 1.
Yep.
Which, Sarah, so are you opening it up and doing it too, or no?
Yes, I am. I'm redoing it.
Okay, good. I was going to say, because it looks like you'd probably lose points if you didn't.
Oh, I did it the first time.
Okay, good. Oh, you already did it.
I did everything I could in prep for the exam for sure.
Does not want me to open it up side by side.
So I start with reading question 2.
Sure.
In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate, master's degree, doctoral degree, of people who manage successful startup companies in the United States and Korea. If you want to determine, if education level of managers of successful startup companies is independent of the country they are from, United States and Korea. Which hypothesis test would be more appropriate for this analysis?
You guys, I don't think this little guy's just gonna be too noisy.
I don't hear him, but I guess you do.
Yeah.
I'll say as long as I can, but
Yeah, don't worry about it whenever you need to.
We kind of need you to tell us if it's wrong and right. I mean, I can sacrifice cute Pierce's little talkings
that's so sweet.
to get it right. I like Pierce. Cute. I want to just throw out there maybe paired sample test. No, hold on. I don't want to say that. I want to say independent sample t-test.
Now, see, I think because it talks about whether the education is independent from what country they're from,
Uh-huh.
we're talking proportions. And we have the test of two proportions. Is that?
Yeah, because I think you're right. It's comparing which the education levels of the successful startup companies. They just happen to be from the US
Yeah.
and Korea, but that doesn't
And
matter.
it's categorical, not quantitative,
How come it's categorical?
because it's instead of giving us a number, it's giving us
Those
This
four
way-
categories.
Criteria, yeah. The
this many had
categories.
graduate degree, this many had masters. This had
Okay.
doctorate.
So it's categorical, so that's why you think maybe it's a two-test proportion? Test
Yeah.
of two?
Yeah, it's got two because it has two different countries.
Nice.
Well, the countries
Or
don't
wait a
matter.
second. Yeah, wait a second. Would that be a
So it might not be two proportion, but
a chi-square?
A chi-squared test of independence? Or an
Because
ANOVA?
I still think it's categorical.
Yeah,
Oh, so an ANOVA is the other one.
yeah,
Okay.
Quantitative.
See how much I have forgotten?
yeah. I think the chi-square, now that I think about it more.
Chi-squared test of independence.
Yeah. Because
Wait,
it would
what?
go into that that one Excel file where it has, you can put as many rows and columns as you want.
Uh-huh. And we'd be putting all four in with the two. We'd have like 4 rows and 2 columns or something, or 2 rows and 4 columns.
Yeah, something like that.
So then are we right, Sarah?
What's your final answer?
Chi-squared
Chi-squared.
test.
Chi-squared.
Hi, that's correct.
Wow, it took us a long time to get there though. That's kind of scary.
But we talked it, and we
I know
read
that
each
means
part
I'm
of
going
the
to have to
question.
do that in my real test because I would have automatically just did the first thing that I thought looked really pretty.
Oh, side note, I found a possible internship.
Oh,
Study abroad in Korea, looking at elementary kids' classrooms.
Oh, wow.
oh my goodness,
Oh,
that would
that'd
be
be
so
so
cool.
cool.
Congratulations, sweetheart. I hope it works out for you.
Wow.
Me too.
When would you
Still have
leave?
to apply. It would be next year, like next fall.
That's so exciting.
Wow.
But
So exciting. Good
see.
luck.
Do you have to know the language? I mean,
Kind of. You have to at least take the one, which I wouldn't mind. That'd be fun.
wow,
Yeah.
that's so cool.
So, we'll see. Anyway, question
That's cool.
3.
Thanks for sharing.
I need to look for exotic things like that. I didn't even know that was possible.
In my life, that's not possible, but I'm glad it is in yours.
See, there's some ups and downs to being single and no children.
Yeah, it's true.
Indeed.
Definitely different. I'll read number 3. A human resource manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years of old or younger and over 40 years. They also reported the number of employees in each group who were terminated. You want to determine if both age groups are treated equally. Which hypothesis test would be most appropriate for this analysis? So We're getting numbers there, right? Quantitative?
Quantitative? So independent sample t-test?
I think so. Independent, yeah. What do you think, Emily?
I'm reading through the question again.
Okay.
Why wouldn't it be a categorical question?
Let's give you the the number of employees that were terminated.
Well, yeah, we were given numbers and categorical stuff.
True.
So you think it might be category like 40 older and 40 younger, 2 categories?
So like test of 2 proportions, you think? It's one of the two, I think. It's either independent or test of 2.
Because you can make a little 2x2 box with the column being less than 40 and then the second column being 40 plus, and then the rows is got terminated, yes, got terminated, no.
And
just
now that, sorry, go ahead.
No, go ahead. You.
I was just, you know, when it's talking about that, it's asking whether they're discriminated against. So they're trying to figure out if one is correlated to the other, right?
Oh, because of age?
Yeah. So that would be the proportion thing, wouldn't it?
That's what I was wondering, because it's like, what proportion of, like, was there a larger proportion of the 40
Yeah,
plus employees who got terminated?
Got it. I almost wonder if you can do both, but I think they want you to do this. I don't know.
So
Yeah.
you think
They're
think
trying to
it's
see if the firings was based on the age, right?
right?
Okay. Yeah,
So
see, when I practiced this, when I went on Saturday, I was like, none of this looks like I've ever done it before.
that's how I feel. That's
Why
how I
did it
feel
look
now.
at me? Well, I don't know.
Do you think it's a test 2 proportion then?
I think it's one of the proportion ones. I'm not confident.
Yeah.
Yes.
Well, it just has the 2.
2, yes.
It has the 2 groups and the 2 amounts of, you know, how many there were and how many were fired. So I think that would fit in the test of 2.
Okay. Let's go with that.
Okay, that's our final answer.
Yeah.
Are we on the right page, do you think, Sarah?
Which question are you on now?
We're on question 3,
And what's your
And-
final?
test of 2 proportions.
That's correct.
Yay.
If I wasn't with you guys, I would have gotten the first 3 questions wrong. Well, at least the first 2 or the second 2. So I'm in trouble.
Well, the first one too, because you wouldn't have participated with us.
I'm in trouble. Hopefully all this helps refresh. Ooh. You know what? I got a new job as a temple worker and I had to give my Relief Society lesson yesterday. So I really threw everything education out the window.
But you should be blessed.
That's what I thought. That's what I was thinking. But so far it hasn't kicked in.
Oh, it will.
It will.
It will.
We're having this meeting.
Yes.
Right.
Okay, next question. A survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 48 were classified as heavy players. Of these, 152 were male. We want to determine the proportion of male heavy lottery players if that proportion is different than the proportion of males in the population, which is 48.5%, which would be the best. It'd be the 1 proportion, right? Test of 1 proportion.
I think so. And it talks about proportion all the time in there. And that's pretty obvious that it's going to be proportion.
one proportion.
And that's another one I got wrong on the homework. Where everything just looked really weird on Saturday. I was too tired, obviously.
Yeah, that's hard to perform. I mean, that's what I did on Saturday night. I've been running all day Saturday trying to, because I flew out at 4 in the morning, Sunday morning. It was a hard time for me to take the test.
Yeah.
Be rested. I learned so much about myself. I cannot perform well on tests when I am wound up like that. There's something about relaxing and having the blood flow and thinking.
Especially on statistics.
On this one, it says, if you want to determine if the proportion of the males heavy lottery players is different than the proportion of the males in the population, wouldn't that be maybe a 2? Or because you're not testing the population, because you already know the population's 48.5.
Holly, that's right. This is the one thing that I struggled, because I was able to meet with Justina, and I went over this. Things that I miss consistently, because I finally was able to look at all this, and to me, discerning between 1 and 2 proportions, because they are looking at 2 different statistics. However, when one is already a fixed, this is what she taught me, when there's already a fixed proportion, that isn't one that we count. That's already an established one, and so we're only worrying about our proportion that we're measuring it against, if I explain.
That's a good, that's good to remember then. So if we see the information already, then we know that one's not one we're looking for. We're looking for 1 proportion now. Yeah,
she called it fixed. When there's a fixed proportion, that's not one of ours.
That's very helpful. Yeah. Very nice.
It was. To me, that helped me. Good.
So we'll call that then the test of 1 proportion.
For number 4?
Yeah.
Yeah, that's right.
Okay.
Cool. Okay, so I'll read question 5. A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open each lock was recorded. They want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate for this analysis?
Okay. So it's quantitative because you're finding the time.
And I think it's...
They got to be paired because each student does each combination, right?
Hold on, I'm trying, that's the question. Oh, because you're comparing that student's time from, well, no, are you?
The difference between the 2.
The difference between the 2.
I say paired sample T.
But doesn't paired sample mean that category A is dependent on category? I mean, subjects A or.
I think you're right. So I kind of am leaning more towards independent.
Well, the thing that I'm thinking is category A is the student with the first combination lock.
Right.
And then category B is the same student with the second combination lock. What do you think?
Oh, I see. They were given the combination to each lock.
Mm-hmm.
And it was recorded to see which one they opened faster. So then is the comparison in how the student does 1 lock per other lock.
I think so.
And that would be a paired.
Yeah.
Okay, I agree with you. I think I like that answer. So Sarah, for 5 is paired sample t-test, correct?
That's correct.
Yay!
Very good at this. Yeah, I didn't do well on those. I studied those. Yeah. If anyone's having a hard time on this, Brother Balls did a whole bunch of scenarios with the answers, and he sent it out on the homework, the notes today.
What, in a video or what?
No, it's just a doc.
Oh, okay, good to know.
Yeah, I would. It's helpful.
You put so many answers in there together, and I'm getting confused at what's what. Okay, I'll read number 6. A bank employs 2 appraisers. When approving borrowers for mortgages, it's imperative that the appraisers value the same type of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study? And I'm almost positive that that's going to be paired, because it's comparing what each appraiser does for each specific property.
For the same
property, yeah.
And you think it's a paired sample T confidence interval?
Yeah. Does anybody have any other ideas? Different?
No, that seems good because the bank evaluates 6 properties that both appraisers valued, and they're comparing what the appraiser appraised from the first. Wait, what are they doing?
So they're comparing each property, how the appraisers both appraised it.
And so they do have to know specifically
which kind of property.
Pair up each property, yeah.
So yeah, I agree with you. So for 6, paired sample T confidence interval.
6. You guys are so lucky.
That's why we needed you to stay on, because I mean,
that's correct. That's good. You guys are good. And you're 100%.
So far, yeah, nice.
Yeah, 40 more to go.
Lagging along like snails.
Were you serious?
In a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decide to construct a 95% confidence interval to see if the observed difference is significant. I want to say interval for 2 proportions. The first proportion being who is satisfied out of the psychology majors, and then who's satisfied out of the accounting majors.
Yeah, I like that.
And then seeing if there's a difference between the 2.
Confidence interval for 2 proportion.
I'm trying to wrap my head around that one because are we trying? I think so, and yet I'm not sure. Usually you're trying to find out if one is dependent on the other.
Not dependent, because this one is asking for proportions, so we don't have to worry about which one's dependent on which one.
Right, but that's
So you find the proportion of satisfied psychology majors, and then in a different category you find those who are satisfied accounting majors, and then you compare the 2 to see if there's a difference. Well, those are 2 different proportions that you had to find. That's what I'm thinking.
Yeah. Like what would your null and your alternative hypothesis be?
That there is not a difference in the number of satisfied people between the 2 different majors. That would be the null. And then the alternative would be that there is a difference in the number of people who are satisfied for each major.
So I was thinking, and maybe I'm wrong, but I was thinking it always had to be, the null had to be that they were independent, and the alternative not independent when we did proportions. Am I wrong?
So you think that they have to be dependent?
Well, I think, and maybe I'm wrong. I'm trying to remember. I don't know.
I like what Emily thinks only because it says observe differences.
Yeah.
You're going to see if you observe difference is significant. So if you're observing a difference, sounds like there's the two proportions. Oh. How come you think it's proportion versus confidence interval?
That's the thing is, I don't know if it is. I mean, I see what you're saying, Emily, and I kind of lean your way because of that, but I'm just not sure because I thought all proportions had to be, the null, they were independent of each other and the.
Are you sure that wasn't just the chi test one?
Yeah, and that's what I'm trying to figure out. Is that just the chi test? Because I could be wrong on what I'm remembering. That's just trying to look at my notes and see, and I'm not seeing notes for that.
Can I
I
ask?
just looked at what was your question?
What is the question?
Go ahead, Leilani.
We're trying to decide. We know it's two samples or two proportions, but we're trying to decide if it's the two proportions or
paired, categorical or quantitative.
Yeah, if it's categorical or quantitative.
Did you guys have a list of words to look for?
Yeah, categoricals like gender, class and college, race, phone number.
I have a different list. I don't have it all with me, but I know for quantitative, there's words like percentage, ratio, or any of those words in this. And this is for number 6.
There's percentage at number 7.
It's for number 7. If the word's percentage, then it's categorical.
If there's a word percentage, or if you're using percentage, then it's categorical.
Uh-huh.
Oh, that's nice. What's that list?
There's a list of words. Let me see if I can find it for you. I have it. I didn't bring all my stuff, but
percentage and ratio.
Yeah, hold on. I'll get you. It's a beautiful list. Okay, you ready? Categorical, proportion, ratio, percentage, brunt, or preference. Nay. That's did I say categorical? Yeah. Okay, quantitative, average, mean, or amount.
Or amount.
And that's not a finite list, but that's the list I got started.
If you go to lesson 18, example 2.4, heading 2.4, in the textbook, it gives an example that you work through. And on step 4, it gives the null and alternative.
Okay, and so I'm not there yet. I have to find.
Lesson 18, 2.4, step 4.
Which number?
Subheading 2.4 and step 4. I mean, you can go through the whole example, but
number 11.
Got it. Okay. Yeah. So then I'm remembering wrong. So it's the chi test that is the only one that's an independent dependent thing.
Yeah.
Or independent not.
Yeah.
I don't think this is a chi test, though.
No.
For
This
sure.
one isn't for this question,
Yeah.
but the independence thing I think is the chi test.
Okay.
Yeah, my sweet little guy.
So what about the whole thing that she was saying about if it says percentage, that's like. Did she say
And it's categorical.
Yep.
So confidence interval of 2 proportions.
Well, that would be categorical. So is this categorical then?
Yeah. Oh. Well, is it count because we're looking for 95% confidence interval? Is that the percentage we're looking at for, or the fact that
No.
we're looking at 2 different majors? 2 different majors is is categorical.
Yeah.
So we're looking at the percentage that are satisfied.
Uh-huh.
I really don't know.
Percentage, I don't think is a good word because it could be used in both.
Yeah.
Yeah. Because this one is talking about what proportion, it doesn't say this, but explicitly, but what proportion are satisfied of the psychology majors. Compare that to the portion of satisfied accounting majors.
Right.
Well, let's not. Yeah. Let's go ahead. I'm sorry I've kept you so long explaining to me. Thank you.
No, it's good. We have to understand it.
Yeah. At least I understand it a little bit better now.
So are we right, Sarah, if we say confidence interval of 2 proportion?
What number are you on?
7?
Sorry, let me get to it. You want 2 proportion. Yep.
Great. I'll read the next one. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that's a true assertion by the company who makes them.
I don't believe it is true.
What?
I said I don't believe it's true.
You'll have to do that sometime. Test it for a party. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amounts in regular Oreos. In which confidence interval would be most appropriate? So we're measuring like weight, right?
Yeah.
Of each one.
So it's quantitative?
Yeah, I'm thinking independent sample T.
Mm-hmm. That's what I was thinking.
Independent sample T confidence interval?
Yes.
Number
Because that one allows us to have compared the 2.
Mm-hmm. Does that sound good, Sarah, for 8?
You might want to look at that one again.
Oh.
Really?
Wow.
Is it because they're paired?
There can't be. You're not pairing one cookie to another.
Because you said if we look for the true mean, then that's quantitative.
It is quantitative.
Quantitative.
But it's not independent samples?
I thought you said an independent sample T confidence. Is that what you said?
Yeah.
Uh-huh.
What else could it be? I mean, it's not paired. It's not one sample.
Why not?
Don't we compare the double stuff to the regular?
This is another one that has a fixed thing.
Oh, it has a fixed thing, but does it ever give us a thing?
Calling Holly Joe, because the regular are fixed and they're not in there. We are only comparing the one proportion of the double stuff, and it got me. Does that help? See, that's another example of it.
But
That's a really poorly worded question because
it is.
You have to know what
they
the
don't give us the
regular
number
is.
for the regular one. If they gave us, oh, the regular has this much,
It's
then
not really implied either.
yeah, it's
I
not.
mean, yeah, they tell us that we only do a sample of one. They tell you that you take a sample of those stuffed Oreos, but you have to do the other two.
You would think.
It would not be the first poorly worded question, though. Would we agree on that?
Wait, so which one do you think it is then?
So it's the one sample T then, right?
One
Or
sample.
no, one sample Z?
You said Z?
No, T.
Oh, T?
Yeah, because we don't have the alpha on it. Or
Well,
the
we
what standard district, the standard, the.
I thought that's what you said originally. One sample T confidence interval.
No, you said one proportion.
Oh, sorry.
Or the independent or something like that.
Samples, yeah.
Yeah, you wanted the independent.
We what? We do want the independent?
Huh?
What?
One sample T test, right?
That's what I think. I thought that's what we had originally stuck with, and she said no. So.
We said the independent sample.
Oh, I must have said wrong, but I meant.
Okay, so one sample, I guess. Huh? One sample T.
Mm-hmm.
That
I think I have the patience for a test.
that one is a bad question because it doesn't say we already know what the regular Oreo is.
Right.
It doesn't imply it either.
Yeah, it doesn't. It doesn't tell us anything like that. That's sad. Okay, well, we'll go with it though. 9. Which one of the following best defines the notion of the significance level of a hypothesis test? I had to look this up in my notes.
The first one, the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
So I looked it up in the notes on the lesson 9 recap.
Uh-huh.
And it was the probability of a type 1 error.
Oh. You said, where did you find that? Lesson 9?
It was, you know how they give us the recaps before every test?
Uh-huh. Uh-huh.
It was in that recap.
Mm-hmm.
Let me just see. Lesson 9. I wrote it down so I'd remember where it was at. Lesson 9 in the last paragraph. It says, a type 1 error is committed when we reject the null hypothesis that is in reality true. Type 2. The value of AA, or the level of significance, is the probability of committing a type 1 error.
Got it.
Oh.
So I would not have remembered that without the notes.
I think I've missed that the last times we've had it.
Yeah, I think so too.
But I
So
didn't know where to find it.
you said the probability of a type 1 error.
Yep.
How does that look, Sarah? Who knows? There's not there.
That's okay.
Yeah.
Hold on.
That one we have the notes for.
Then which following defines the notion of a p-value of a hypothesis test?
Oh, that one would be,
Number 3?
yeah.
Yeah.
Okay.
That one was a little bit easier for me, but I still found it in the notes
Mm-hmm.
to make sure.
Significance level. I have to remember that one on 9 because that's harder.
And that's in lesson 10 recap as well. It's almost word for word in there.
In lesson 10.
In lesson 9.
Oh.
Okay. Suppose you create 95% confidence interval for a mean and get 10/20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. What does this mean?
I think number 2. 95% of all 95% confidence intervals contains the true mean.
Ding, ding, ding.
I think so too.
Wait. One, or 4? Oh, I think it would be 4.
I don't think we use the word chance. And that's the only way I know this one is because I don't use that word.
That's correct, Holly.
Yeah. And it just seems familiar, that second one, 95% of all 95% confidence intervals actually
Yeah.
contain the true mean. That one I remember hearing.
Yeah.
I don't remember that one at all. Okay.
Huh.
And that's what helps me with that one because I really don't know what that means, but I do know what words not to use and what words to use.
That's
so.
right. And that one, often when it says 95% of all of 95%, that's one of the right ones.
Yeah.
Which is weird, but yeah, that's right. And it makes me think about it. The other one that they say not to be really careful of is when they make it sound right, but when you look at it carefully, that it's including all the data, and that's never going to be right.
Right.
95% of the data or of all of it, and it's like, no, it's a bit true meaning.
Right, that definitely won't be the third one.
I have such a cute grandson. I just have to take some more pictures. I'm sorry. It's just so fun for me.
Okay, so for the, we're going to use information to answer the next 3 questions. You take a simple random sample of 100 adults from the town in the Western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in the town who invest in the stock market is P equals 0.30 or 30%. What is the mean of the distribution of the sample proportion? How do we do this?
Now, isn't that one just the easy 0.3?
Oh, because P is the mean, is that right?
Yeah.
Yeah, I think so.
Okay.
One of those, oh, you think it's going to be hard, but it's not question.
Right. It's trying to throw me off, but it's, so would you say 0.30?
Mm-hmm. That's what I would say.
What do you think, Sarah, for 12? 0.30?
Right.
Oh, that's lovely. And then it says, what is the standard deviation of the distribution of sample proportions?
Trying to remember how I did that. I finally figured it out, but now I don't remember how.
Is this a formula?
I think so. I would have written it down.
Is this a categorical formula?
Oh, is it the standard deviation equals the square root of P times 1 minus P over N? That sound right?
Say that again.
Standard deviation equals the square root of P times 1 minus P over N.
Yeah, I think that's what it is. These are what I did not bring my little cards. You know, I write my formulas on those little 3x5s.
Mm-hmm.
I didn't risk dragging those across the country.
Yeah.
But I think that's the right formula if I recall.
Okay.
Yeah, I wish I could find mine. That sounds right.
Mm-hmm.
And that's all the information we have. So
Right. Which is, I think, is why I used that.
The square root of P divided by N.
Square root of P times 1 minus P. Divided by N.
So if mine's right, I got 0.046.
That's what I did too. Is that what you got, Emily?
I was still putting it in.
Oh, fine. And that was one of the options on our homework.
What did you get?
0.046.
Yeah.
What'd you say?
Yes. That's what I got.
How does that look, Sarah, for 13.046?
What's your total full answer? Because that's too many digits. Sorry, I've got to get this little guy.
Oh,
What number are we on, hon?
13.
13. And you want to say it is what?
0.046.
That's what I got. And that's correct.
Oh, good. I was going to say, if that's what you got, did you get the answer right?
Well, I did really well on all those. I was thinking it up on those tests, putting a test on them. And you guys are struggling on them too. So, and you know what? Justina said that is really what everybody in the class is having the hardest time on. So
What? Just
finding what test to put to apply. The section where we just finished.
And that's because there's too many now. There's just too darn many.
Yeah, keep them all separate.
We should just protest.
Come on. Stick with 4. We don't need 18. Okay, are we ready for 14?
Yeah. Number 14 is another formula. What's the probability that your random sample of 100 adults will have a sample proportion of less than 0.25? So we're trying to solve for the z, right? And then
Put it in the applet.
I think so. So z is the value minus the mean over the standard deviation.
I have too many notes. I can't
Yes.
find my right notes anymore.
I know what you mean.
Over.
It's really scary.
And we just found the standard deviation, right?
Yeah, that was question 13.
So then
And so what's this formula?
So it's z equals
Mm-hmm.
value minus the mean divided by standard deviation.
Okay.
That's the word I was trying to say.
And so the value is that 0.25?
Yeah.
So it's 0.25 minus 100?
And minus 0.3.
Oh,
So
I
the
thought- 0.3 divided by 0.4046.
mm-hmm.
Okay. That's the equation that we're looking for. And then we put this in the applet thing, or?
Yeah, that's a z-score.
Okay. We only lighten the left side.
yeah. I got 0.138.
Or 139, one with a 2.
Huh?
Oh.
139?
138.
Okay, because I have 1385.
Oh, I had 1.1376.
Okay, what did I put in wrong?
What did you put in for your z-score?
Negative 1.087?
Huh.
My z-score is really off.
What was your z-score that you got?
I'm not even telling you because it was so off.
What did you put as your standard deviation?
Well, I'm going to try to put it in parentheses and see if that helps. because it was really
Leilani, what
bad.
did you put? Did you put 0.046?
Let me see.
I have negative 1.0869.
Huh.
Is that wrong?
But you know what? When we did it on the homework, it gave us 4 answers. You have to choose one of them.
And then you can plug it in.
Yeah, well, their answer is that's closest to either one of ours is what you've got, Emily, 0.138. And I don't know why mine's coming up 0.1385, but
What did you put as your standard deviation?
let me see. I put exactly what we had on the quiz. What, 0.046?
Oh yeah, so you rounded early.
Ah,
For that one, you should unround it and put it in.
okay. That's funny though, because we already have the answer, so you just want to use that,
Yeah.
but I shouldn't have.
So
Got
what
it.
the answer is 0.138? Or no?
Yeah.
I
So
got 1.385 too.
Yeah,
yeah,
rounded.
you put in 0.046 as your standard deviation, right?
Yeah.
Yeah, that was rounded, and so if we want the most exact, we have to
How
go
did
back
you?
to the. Huh?
Yeah. How did you get it unrounded?
Well,
Oh,
I
you
can
just
show
went.
you my.
You just went back and
Well,
found what you had before we rounded it.
Yeah, but I made it easier on myself by using a calculator. One sec, I'll show you. This calculator, desmos.com.
Oh.
And so then I put in this up here. Oh, one sec. 0.25 minus 0.3 divided by, and then I clicked answer, which puts the previous answer. So
Oh.
when I found the standard deviation,
Okay.
that was the answer. So you guys can do it on your calculators too. That's what the ANS button is.
Wonder if my calculator has an ANS button. It doesn't.
Oh.
Well, I'm just using the one on my computer, so
What's that website called?
that's cool.
Desmos, desmos.com.
I
And
might
it's a
try that.
scientific calculator.
Because I'm having a hard time with mine.
Misplaced my calculator, and the one on my computer wasn't sufficient for what we were doing, so
Right.
found this.
That's a nice one. I like that.
I'm pulling that up now. Okay. So I'm hopeful on that. If we had been 0.139, we still would have gotten credit because it was so close. But I don't know.
You could
What wasn't the way?
ask, yeah.
Mhm.
Well, I have to go to class, so
No.
good luck.
Sorry.
Be
You can do
late.
No, it's
I
been an hour.
can't.
I'm going to.
It's the
No,
last
don't leave there.
rehearsal.
You guys are doing great. Honestly, as far as the this quiz, that first part was a hard part. The rest of it is pretty straightforward. You'll be fine.
Because it's what we just did in this unit,
We have to
right?
rely on you, Leilani, because I'm not.
I don't know about that. Let's goes.
Yeah, you'll be fine. It's good. Good
Just
luck.
don't round too early.
Being happy. You guys enjoy. Good luck on your quiz.
Okay. Thank you.
Thank
Bye-bye.
you. Bye-bye.
You both.
Don't round too early.
Okay.
Don't round too early.
Okay, bye.
Bye. Good
Thank
luck
you.
in your class.
Happy Thanksgiving.
Okay. Are we ready to do this?
Sarah did not need to leave us.
She's feeding a baby and another one.
You can tell that I've never had children. I do not understand why she's so stressed out. So we have 0.138 for number 14.
Yeah.
Okay.
Well, I can at least go back to, see, the homework that we did for this was exactly this.
But you didn't have like an answer sheet to tell you whether you did it right or not.
No. I have what I did, and
Sure.
I'm not confident about all of it, but there's parts of it I'm confident on.
Oh, good.
So that'll help. Okay.
I trust you. I just know that I'm not a lot of help, so we're pretty much kind of leaning on you right now for you to basically help remind me what I don't or do know.
You are too. You're great.
Well, I don't know. For some reason, I'm having I can't even find my notes to those equations you just found, you know?
It took me a long time. And like I said, Saturday, I was like, what? Have I done this before?
Yeah, this is really difficult.
I don't know why. I really think I was just tired. Because I've found if I do statistics at night, I'm in trouble. If I do it in the morning, it's okay.
Yeah.
It's weird. Anyway, we might as well give it a try.
Okay, so this next one is for the next 7 questions. Acupril is meant to control hypertension. In clinical trials of Acupril 2142, subjects were divided into 2 groups. The 1563 subjects in the experimental group received it. 579 subjects in a control group received a placebo. Of the 1563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 in the control group, 15 experienced dizziness. That's interesting, as a side effect. Let P1 be the true proportion of the people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experience dizziness but did not take it. So P1 is the true and P2 is the control group. Create a 95% confident interval for P1 and 2. Input the margin of error, lower and upper bounds below, rounded to 3 decimals. What is the margin of error for this 95% confident interval? So I need to pull up my my quantitative inference.
Or the categorical, right?
Oh, categorical.
I think so.
Because it's numbers.
No, quantitative would be numbers.
Oh my goodness, I'm already getting all so confused. Categorical. Oh, I pulled up both my quantitative.
Talking about doing proportions. So that's how we can.
That's how you know that.
Proportions, yeah. So.
Which one had to pull up then?
Just 1 second. I'm having a hard time getting my screen to go side by side. Why won't you do this?
Oh, here, categorical data analysis. I think I found that. Okay.
Okay. So if we go with the X1, N1 inputs, so how about in X1 we put the experimental group that experienced dizziness, so 61 in X1.
61 out of 1563?
Yeah.
And 579. Oops.
Oh, 15 out of 579.
Oh, 15, thank you. See, I mixed those up too a lot. 579. The 95% confidence interval. And if doesn't matter whether we want to be doing it equal to or less than or more than.
I'm looking at doesn't say yet.
Input the margin of error. The margin of error, I think, is 0.0161. No, 0.016.
Let me see really quick. Where do you get that margin of error?
This is the one where I do the high minus the low divided by 2.
Exactly, got it. And what did you find for that? It's
0.016.
That makes sense.
Does it?
Yeah.
Okay.
As if you add the 0.029 plus the negative 0.003, you're going to get a 32. So half of that is 16.
Okay. And then our input lower bound would be negative 0.003.
I don't know. It just told me that that wasn't a valid number. I need to change whatever I did. think I put 2 points. So just one. Go back there. Didn't want to take that. Okay. Yep, lower bound. Negative 0.003. Save. Upper bound 0.029.
Yeah, that's what I have too.
See, those are easy. Yeah, we've got that.
Yeah, I wish they'd have those all day till Monday.
Yeah.
Till next Monday, because I just don't like to have to figure out what I'm doing. But once I have to do it, I can do it.
Exactly.
If that makes any sense at all.
Yeah. Okay. Question 18. Perform a hypothesis test to see if the proportion of the experimental group subjects who experience dizziness is different than the proportion of the control group subjects who do. Use a level of significance. So we're trying to find difference. So the null is always they equal, so it's one of the first three. And then we're trying to find the difference. So the alternative would be they're not equal. So it's the first one, right?
Oh, because that's just what we're wanting to look at what our alternative. Okay, yes.
Yeah, they just want to find out if they're different. They're not trying to say one's.
See, I was already going to try to figure it out if they were like high, P is high or whatever. So they were tricking me.
Yeah, we just need to put in the hypothesis.
The appropriate null and alternative. Okay.
Okay. Value of our test statistic is over here on our chart.
Is it on our chart? Which one is it? The
Z.
It's what the Z.
Mm-hmm.
So 1.48 or 458.
Yeah. I went ahead and changed our type of test too, because that's going to make a difference in question 20.
What do you mean?
The type of test is not equal to.
Oh, but will it change? Did you change it already?
I just barely did. It didn't change the Z, but it changes the P value.
Okay. And so you put it to not equal to, and then the P value would be 0.145.
Yeah.
Okay. How do you kind of remember that Z is equal to test statistic? How do you remember that?
You remember we have the sample T and the sample Z. So those are our
same test statistic.
Yeah, either T. I'm having a hard time with the word statistic.
I know, me too. Test,
especially if you say
statistic is a tongue twister for sure.
Exactly. So yeah, because you have the sample T test, then your test statistic is T. A sample Z test is Z is
the T.
Yes, test statistic.
Okay. I'm glad that I'm not the only one that has that problem, because I can't say it either.
I have problems with words.
Me too.
Give me numbers. I got numbers.
21 is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? Is there a difference?
We are failing to reject the null.
Because the P is high, so we're failing to reject. So that's a no, right? No, I failed. I failed to, wait, how do you say it?
No, I failed to reject ho, as you call it.
Yeah? No, I failed to reject ho. Okay, because we're failing to reject the first one, ho.
Mm-hmm.
Okay. That was going to confuse me for a minute there. I was wanting to fail to accept ha, but I don't know why I would want to do that. I've never done that before.
Yeah, we never fail to accept or reject or whatever. If it says father, it's automatically wrong.
Right. Okay.
Well, here we go again. Another one.
Okay.
Oh, it looks like we're going to use the chi-square. Whenever there's a chart, that helps me know that there's a chi-square.
I like that one.
Yeah, that helps.
There's no confusion there.
Yeah.
Uh-oh, I can't find my case.
It's on that same categorical data analysis.
Oh,
Excel. But it's, just on the bottom, there's 1 proportion, 2 proportion, chi-square.
okay. Found it.
You see it?
Thank you. Yeah.
Good.
I need to bump it up so I can really see it. So should I put those numbers in like how they have them there, morning and evening?
Yeah, I just put in 97, 177,
Okay.
the 4 across and 2 down, and then I erased what was on row 3.
Okay. Okay. So a survey was conducted of 1279 random selected adults age 18 and older. They were asked, are you a morning person or a night person? The hypothesis for this test or the study is, and so what did you say with Kai, that they do have to be dependent, or they are always dependent?
So
No.
like the null is they are independent.
Independent.
And the
Ha is that they're not
independent.
Okay. And so that's what it's given us. And then there's so conduct a test of independence. Use the significance level A of 0.05. 0.05.
Yeah, I don't think we need to put that anywhere in right now.
Okay, good. See, I'm even getting confused about how I use each one.
Right.
So calculate the test statistic for this hypothesis test. Assume the requirements are satisfied. So is it 6.579?
Yeah.
579.
Mm-hmm.
And then calculate the p-value for this hypothesis test. Assume that the requirements are satisfied. 0.087.
Yeah, I'm trying to decide whether to round
Bring it all up. Yeah, because I don't see anything here that says to round.
Yeah, usually it says to round it.
Uh-oh.
Let me look at the homework. In the homework, it has 0.087
Okay.
as one of the possible answers.
Okay.
So I guess we'll round there.
I like it when they give us 4 to choose from.
I know. The last, last 4 questions didn't have choices.
I know. I hate those ones. Even though sometimes they're easy though too, but.
Yeah. But it doesn't give you that, oh, well, mine's there. So obviously, that makes you feel better. Okay.
So should you reject the hoe or not?
No, it's too high. P-value is too high, right?
P is high, so that's no. That's failing to reject, so that's no.
No, the p-value is greater than 0.05.
Uh-huh.
There we go.
And then what do you conclude?
We have
Insufficient evidence, right? It's insufficient.
It's insufficient evidence to say that it is not independent. Is that right? Because our second one, our alternative hypothesis was being a morning
Not independent.
Not independent. So yeah, we don't have evidence to say that. Insufficient.
Correct.
Yeah, so it's very last one.
Okay.
Alrighty. I'll read.
Okay, go ahead.
Ready to go on?
Uh-huh.
A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. So, based on the results, create a 95% confidence interval of P. Alrighty.
Are we using that same one then?
I do not know.
Not that one, because that was category, or that was Chi, but because we have a random sample of 200.
Mm-hmm.
That PB that, oh, so maybe we just do one proportion?
Yeah, let's see what happens if we do that. One proportion to 200.
And 200s are N.
Mm-hmm.
And
50 is the X, right?
is that what it says? 50? 50, yeah. And then 95% confidence interval. And then what's our null?
That's what I'm looking. Our null is 0.2.
Where do you get that?
From the 20% is, I don't know.
Let's see.
Let me see something. I think it is because you're using the numbers that they give you, from the history.
Uh-huh.
They said that only 20% is, they say in the recent book, so that's what we're comparing it to.
Gotcha.
That's right or not?
Mm-hmm. That seems right then.
And are we trying to decide if they're different or if they're...
50 of these outperformed. Let that be the true. And who outperformed. That means higher. Greater than? Outperformed would be greater than.
Yeah, I don't know if we even know that number yet, but I don't think we need to know it yet.
Okay.
So put the lower bound.
Yeah. What do you have? I have 0.190.
Yeah. And that one does tell us to round. Upper bound, 0.310.
Uh-huh.
Suppose you're in charge of designing the study. What sample size would be needed? Size. There we go. Went down too far. What sample size would be needed to construct a margin of error of 2% with 95% confidence?
What sample size?
So, sample size. Let me see if I wrote. That would help.
Would it be 200? Because we have to use 20? Would it be 20?
I'm trying to...
I can't remember how we get this, but I think it's...
Yeah, what did I do?
There is a specific thing.
There is.
I remember you doing it before.
Yeah. Okay, so do we have a prior P? Yeah. Okay, so if we have a prior P, then we have N equals P. So I'm going to get out my calculator now.
Okay.
I'm going to open up my calculator, so if you can tell me numbers after I open it up.
Okay.
So the P was 0.2, right?
Mm-hmm.
And then we're going to times that by 1 minus P.
Okay.
So 0.8.
times.
And then times that by Z over M.
Uh-oh, what's a Z? Okay, Z is,
1.96, right?
are you ready? Is 1.768?
Is it 1.768 for 95? Or is it
Yeah.
1.96?
For 95 confidence interval, it's 1.768.
How did I remember the other? What is that? Okay, can you tell me that again?
Yeah,
1.
1.768.
Some reason I was thinking that was the 90%. Okay. And then divide that by M. What is that?
What is our M?
That's what I'm trying to remember.
200 or no? 50? Oh, or M, it means the mean.
The mean. So would that be the 0.5?
I don't know.
Oh, the not 0.5. The mean of 50 over 200. That's 0.25, right?
0.25.
I think.
Does the answer look right? What did you get?
I'm not sure what the answer is supposed to look. It does not look right.
I think the answer will be 20, but I don't know why I think that.
I'm trying to find this on the homework. Okay, let's see. Darn, my battery.
We're trying to find the p hat. No,
Yeah.
the
Or no,
the
we
P-
have we have or
point estimate, or what is that P with the star?
well, we have the P with the star already.
Because it says use your prior estimate of P star equals 2.2.
I have to move into the other room and plug in my computer. Sorry.
Uh-oh, okay.
I'm still here though.
Okay.
I just like going in the other room because there's more sunshine, and I do better with more sunshine.
Yeah. Yeah.
Okay. I'm looking at the at the assignment, the homework assignment, and you can see the answer, and that is not what I got.
Is there a 20?
No, it's quite a bit bigger than that.
Oh, okay. So I'm really off on.
But I don't remember where I got it.
The mean? No, we're not. So what we're looking for is what sample size. We're looking for N, right?
Yeah, yeah.
Okay. We're looking for N, so I need to find my formula with N.
Mm-hmm. Oh, I forgot the squared part.
Oh.
There we go. That would make a difference. This.
Oh my goodness, I'm gonna have to get everything organized before I can do the test because I can't find any of my formulas.
That's what I'm thinking too.
I guess that's why they had us print out that one paper and we're supposed to put it all on there.
Yeah, and I haven't gotten that all done. I've done parts, but not all of it.
I'm not finding my formula for N.
I have a formula, but it's not working. It's not doing.
What do you think it's for this one? What is the formula?
Well, let me look at something really quick here.
Yeah, I'm wondering what lesson I could look into.
Yeah. You know, when I have the z-score, I have it, it's 1.96.
Your z-score?
Yeah,
Um,
add that again.
sorry, are you on the one sample z test for proportion?
Where's that at? What lesson?
Well, no, you're like on your, which one are you using to get your calculations?
So I was looking at my notes because this.
Oh. Because
No.
I put this into the one sample z test. Maybe I should be putting this into a different one.
Don't know. Yeah, I'm totally messed up here. I have everything in a mess. What? I'm still not quite sure what M is. That's my problem. I don't have an M.
How come we have to find an M on this one?
Because it's in the formula to find the N.
Oh.
So the formula to find the N is N equals P hat times 1 minus P hat times Z over M squared. Do you see that formula?
I don't, but I just wrote it down real quick because
That should be in lesson 17.
okay, let me look over there. Just I'm not finding it on my notes. Lesson 17.
Mm-hmm. In the recap that they give us, it's the very last paragraph on the recap.
Okay. Formula for N. Okay, and we don't know what an M is then.
I'm trying to remember what M actually even is, which is kind of sad that I don't.
I don't have it written. Wait, maybe I do.
Like my mind goes blank, and even if I knew it, I don't know it. M is margin of error.
Okay, M is margin of error, which is z star.
At least it is sometimes, which is the upper bound minus the lower bound, right?
It's the z star. Well, if we're in quantitative, wait, we're in categorical, aren't we? I don't know, because I have a margin of error. Another formula for margin of error is a z star sigma over n square root.
Yeah, I have that too, but we don't have sigma, right?
Or did we just find it? Oops, did we just find that out?
No, I think because sigma is the. Or what is sigma? Sigma is the standard deviation.
Sigma is the standard deviation, yeah.
We don't have that, do we?
I'm looking to see what we had just figured out.
Confidence.
Yeah, we do have the standard deviation of the hypothesis test.
Oh.
But.
And the confidence interval.
And the confidence interval.
Yeah.
And so, would we use that, do you think?
Or should we just use the upper bound minus the lower bound divided by 2? Right. Let me try that and see what happens. So that would be 0.12, so 0.06.
Oh, I see what you're saying. For this one to find basically the margin of error.
Yeah. Still not giving me.
It'd be 0.215.
0.2 what?
0.215.
What's 0.215?
That's the high minus the low divided by 2, which is kind of close to what I thought, 0.20. But do you, on the homework, does it have those options?
Let me look.
Yeah.
What? Well, what did you get for the answer? Because
0.215.
but that's just solving for M. We need to put that in the formula.
This is what sample size needs to be, what sample size would be needed to construct a margin of error. Yeah, you're right. So 0.215 would need to be put into that equation that you have there.
Okay, I put it into that equation, but that does not fit anything on the...
Okay, so then maybe we should try this other margin of error one, which is the Z star, but do we have the Z star? Because it says the Z star.
There is the 1.96. That's the known...
Yeah, so I wonder how you got 1.96. Do you have that in your...
That's the critical value Z star that works for everything. It's always that.
Oh, thank you. Okay, gotcha.
I didn't get it on the page anywhere.
You're right. Okay, so 0.196.
$1.96, sorry.
Thank you, because I think I was saying that wrong. But now I'm trying to find my notes to even tell me that. I'm so sad. I wish I had known to mark on my notes quantitative on the top, because then when I started doing categorical, it would have been really nice just to keep them separate.
That's a good idea.
But it's kind of too late now.
Well, it's not too late, but it would take a while. Oh, that might be too late. I don't know. Oh boy.
Okay, yeah. So yeah, that margin of error, that's a different kind of margin of error. I never understood how we used one versus the other.
Yeah, I don't know.
Did you say that, what is that 0.1 what?
The Z star?
Mm-hmm.
1.96.
1.96, thank you. Okay. And our N is 200?
Yeah.
I don't think I have a right answer.
What did you get for M?
I don't think it's right because it's 0.004.
That's what I got too.
Oh, really?
Yeah, I can put it into the problem and see.
Okay.
I'm guessing not 38,000 something. I hope you don't have to do that big of a sample.
So that is not. Here's a formula for a sample size, and yeah, that's what you have. That's what you're doing right now, huh? Z times sigma divided by M squared. Okay, let's try again then.
Oy, oy, oy.
1.96 times, what are you using for sigma?
Well, I used the 0.0306.
Okay, I have a different number than you.
Well, there's also 0.0283, depending on which one you want. Gives you the deviation of the confidence interval, and it gives you the standard deviation of the hypothesis test.
Yeah, which one do we use?
My goodness.
Oh,
this is sad.
yeah. See, that's the thing. It's too many options.
Somehow I did this on Saturday. I have an answer, but I don't know if it's right.
What's your answer? Oh, so we're trying to get close to your answer.
Well, we're trying to get close to any of the answers on the homework.
Right. Yeah.
So,
that's a good idea.
So there's 5 different answers. 2,401 or 1,537 or 16 or 1,801 or n is larger than 30, which, yeah.
Those are all the possibilities?
Yeah. And I have what I put, but I don't know how I got there.
Did you get 192?
I got 1,537,
Oh,
but I don't know how.
yeah, and I got 192.3.
Ah. Let me just tell you something.
What?
In the problem, it says construct a margin of error of 2%. They give us our M. M is 0.02.
Okay, thank you.
But
Okay, let's try that. Let's try
how
that.
did I miss that? Okay. At least it finally came to me. Okay.
And are we sure that 1.96 is the right number for our Z? Because
Yeah.
that's the part I can't find my things to tell me. I have it written like 5 different places. Okay, here. Okay, yeah. And so now really the question is whether we're using the right sigma or not.
We don't need a sigma.
I thought we do. I thought it's Z times sigma divided by M.
They give us the M.
But the
Don't need to solve for M.
we're solving for sample size, and I thought that was N.
We're solving for N, not M.
Right.
So N, where's the?
I thought it was
Is P hat times
P
1
hat.
minus P hat times Z over M
okay. Gotcha.
squared. But I just couldn't figure out M until I'm looking at the question going, they tell us M. Yes. Why do I make it harder than it is?
We like to do that.
Yeah. No wonder I can't find M. It's in front of my face. Okay. So do you have that in your calculator? Did it come out?
I'm putting it in still.
Sounds good.
So the margin of error, how will I put that in? 0.02?
Yeah.
I don't think I have the right answer because I'm not being able to put in my parentheses right. I have like negative 9.81803.
Yeah, I used the calculator that Emily was showing us.
Yeah, I never got that one going yet, but
What if you do 1.96 divided by 0.02?
divided by?
Uh-huh.
Okay, hold on. 0.02.
And
Then what?
Get that answer and then you square it.
98 squared.
Mhm.
Oh. This is where it won't let me. Not square root.
Squared.
Okay,
So times 98 times 98.
let's just do that.
Mm-hmm.
9,604.
And times that by 0.2.
1920.8
Times that by 0.8.
is 1536.64. 0.64.
Yep.
You think that's an answer?
So it's 1537.
And that's an answer that's on the homework that could be?
It is.
Okay. I don't know how we got that, but I love that. So that's good.
Well, we just plugged all the numbers into that equation that we had.
See, but it says what sample size would we need to construct that? So this sample size is way larger than the one that we're using.
Yeah.
Do you think that's right?
Yeah. I don't know. It's to get it to a really small, I don't know.
Because the sample size, it says what sample size would be needed to construct in order to make it a smaller margin of error, basically.
Yeah. Exactly.
I have to think that through a minute. Because the margin of error up there, well, I guess we'll put that because that's what's available to us.
Yeah, exactly. But yeah, it's what we've got. It's the best. We followed the formula, and that's what it gave us. So it should be good. It was one of the options.
Yeah.
Oh,
Suppose you wish to see if there's evidence that graduates from one of the top 10 business programs perform better than the other investment managers. Conduct a hypothesis test using a level of significance 0.05. Which of the following pairs of the hypothesis test is most appropriate for addressing this question?
okay. The whole is always, it equals the 0.2.
Mm-hmm.
Got to be one of those three options. And the alternative is that they perform better, so P should be larger than 0.2. So I'm looking at the fifth one.
Okay. 1, 2, 3, 4, 5. Yeah.
Does that look right?
I think so. I get a little bit confused when it comes to which way the alligator should force. But basically you're saying that the P, the null will be greater than the 2?
No, the P is not the null, but the...
Gotcha. The ha. The ha's new answer is going to be greater than what the ho was.
You're trying to prove that, yeah.
Okay. And that's what that's. Okay. Yeah.
Okay. 30. What requirements must be met
To ensure that P is normally distributed.
Is it the 5-1?
No. I think it's the first one. Oh.
I'm trying to find that on my notes.
Yeah, I'm not even going to try to find it on my notes, but because the P hat is before we learned about the chai, and the chai is the only one that's about the 5.
Oh, is that right?
Or the chi, or how we say that. So that very last one's the only one that has to do with 5. Everything else before then has to be with 30.
30 or 10?
I don't remember. Actually, I think 30, but where did the 10 come from?
That's, I'm trying to, unless an 18
Unless an 18?
has a 10. And that was when we learned about the proportions, right?
Oh.
So it's NP is larger than 10 or 1 minus B. Yeah, I think it's the first one.
Okay, that's what I was thinking. We found that in lesson
18.
Okay.
So our test statistic here is the Z, I think. The Z.
Test statistic. And so for Z, do you have 1.768?
Yeah.
And the P value is 0.039.
Yeah. Is there sufficient evidence to conclude the graduates from the top 10 business programs perform better than investment managers? Is it our confidence level 95? Or level of significance A is 0.05. So yeah, it is. Yes, I reject the null.
Yes, I reject the ho. So the top one?
Yeah.
Okay. Ooh, this one's long. Use the following information to answer the next 6 questions. You know they're giving us a whole bunch of information we don't need.
Yeah, just skip the first. We're going to skip the first paragraph. I don't think we need that.
Okay. Okay.
To compare Pharaoh's ability to translate with similar computer translation software, Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharaoh to translate each of these to English. The blue scores calculated for each of the 100 blocks. The scores are recorded in that data file. He wants to use this data to see if his mean blue score is different from the mean blue score of another leading translation software that has its own mean score. So is this going to be, are we putting this?
Because we're using the mean, so is this quantitative?
I think you're right. Yeah. So I'm going to open up quantitative.
Which one are quantitative inference or quantitative descriptive statistics?
Quantitative inference.
Inference, okay. Quantitative inference. And do we know what kind of test? Are we looking at two different things? Or?
Well, we're looking at just one different thing.
One different thing. So it's a one sample t test.
I'm just copying and pasting this line of numbers real quick.
Where are you going to paste it?
Yeah.
To a one sample t test?
I think that it's a one sample t.
Okay.
Because we just have the one sample.
To write in there.
Mm-hmm.
Okay. So, and we want to do 95. And do we put our null hypothesis as what? 95 as well, or how do we?
Just a minute. What?
My mean's a little bit lower than they say. They say the mean's 0.295 and my mean's 0.20288.
Yeah, we're trying to compare this mean to the mean that they give us from a different software.
Okay.
It's a different software. So we have the confidence interval for question 34 and 35 right on our chart. So 0.282 for the lower bound.
Uh-huh.
And 0.293 for the upper bound.
Mm-hmm.
So our null, I think, is the 0.295 that you were talking about.
Okay. That's what I have on there.
And see if it's different than that, right? And different, not greater than.
Oh.
Not equal to.
Degrees of freedom 99.
Mm-hmm. Test statistic. A -2.
Wait, so should the null be 0.295, you said? Or no?
Yeah.
It should?
I think so. Because we're trying to compare this new one to that.
Gotcha.
If it's not equal to that.
Oh, that does change some numbers.
Yeah.
So our test statistic is, do you have -2.803?
That I have. Hopefully that's right.
Yeah. And then the MP value is 0.006.
Uh-huh.
Based on the results of this test, what would you conclude using the level of significance of 0.05? This is smaller than that, so It's low, so we reject the null. So we say yes, we have sufficient evidence to say that the true mean is different than that.
Yep, I think that very first one.
Okay. That was lucky.
Okay, I think we're on our last one though.
Yay!
Whew. Okay. A study was done to test the notion that people are taller when they first wake up in the morning than in the evening right before they go to bed. And that's because of the tests they're taking.
So true.
To test this theory, the heights of children in boarding school in India are measured. Values are recorded in millimeters for each child in the morning and again in the evening. The data is recorded. You may want to determine, or you want to determine if the children are taller in the morning than in the evening. Define the differences as AM height minus PM height. Construct a 95% confidence interval for the true mean difference of height and conduct a hypothesis test at a level of significance of 0.05. Okay, so this is a paired sample test.
But is it categorical? No, quantitative?
It's quantitative.
Quantitative?
Heights are all in numbers.
Quantitative paired.
I'll pull up the chart here.
Quantitative paired. Oops, not that one.
So we have the quantitative inference procedure.
Okay, thank you.
And then just go to the paired sample T.
Okay. And then we want to be putting these in as AM in the first column and PM is the second, does it say, or no?
Yeah. Oops. There we go. Yeah, it's AM and then PM. We've got this. We're almost there.
I wish this was the real test.
Oh, that would be
we were over and it says, you've done well.
Yay.
And what's sad is this is not the last test. That's what makes me sad. I wish it was.
But it's so close.
It is. It is close. Okay, so we're wanting to input the lower bound of your confidence interval. I think that I have 8.728. If we're looking for, and we're wanting 95%, and we're wanting not equal to or different. Yeah, not equal to.
We're trying to find if they're taller in the morning. Right?
So what would taller be, greater than?
Greater than, yeah, I think so.
The morning, or the morning greater than the evening. Okay. If we put them in right.
Yeah.
They don't tell you to put them in first, do they?
Put which in first? What?
Did they tell us to put the AM in first?
Yeah, it does.
Okay, good.
It says define it from AM minus PM.
Okay, gotcha. There it is right there. So
we have the upper and lower bounds.
The upper is 10.455.
That's a high test statistic.
Mm-hmm. A test statistic is 22.446.
Uh-huh.
Degrees of freedom is 40.
Mm-hmm.
Your p-value is
0.000.
Really?
Well, it's to the negative 24th.
Oh, gotcha. Because I see the E.
Yeah.
I was going to put in some numbers there. So 0.000. Thank you for that.
Mm-hmm.
Based on your test, is there enough evidence to suggest that children are taller in the morning than the evening? P is low, so we reject the null. So yes,
Reject? No. Yep.
Because we rejected the null.
Okay, I'm going to submit.
Okay, and then I'm going to tell us which ones we got wrong or right. You submit first.
I am. Chose to submit. Let me see. I'm going to go clear down to the bottom. Okay, we missed one.
What number?
Really good. Let me go up slowly and find what number. That's awesome. Number 35. Well, that's weird.
35?
Yeah.
That was a...
You would. Oh. What did you get on 35? What did you put?
0.293.
Yep, missed the point. So you probably got it right.
Oh, because you just put 293 in and you forgot the point.
How I missed the point. Frustrating.
Well, that's I'm impressed that we got them all right.
You know what? I don't think I'm going to go back and redo it.
No.
That's a lot
It's
of
not worth it.
problems to redo.
It's not
right
even
now I
worth
have a
it.
97.6 on this. I think I'll take that.
Yeah, I think that's good. That's
So did
good.
you get 100?
I did. Thank you.
Yay!
Thank you for staying with me till the end and
We
helping me.
Darn decimal.
But
I
you know, it
I will go for that.
seems like he should be able to see that and say, "Oh, she knew the answer." So
Yeah, because I'm like, how did I get one of the bounds right and not the other? It doesn't
right.
make sense. Okay, well,
Yeah.
that's all right. I'll take that because I could easily go on and fix it, but that would be like 40.
All that other stuff.
Take a while. It's a 45 question test.
Yeah.
Do that.
When are you planning on taking yours?
I'll probably take it tomorrow morning because that's like my only time I won't have a bunch of distractions around.
Uh-huh. And
the
it sounds like you've already checked. You already checked your prices. Have you already done that?
I did.
Okay,
I
cool.
did.
So I'll go over and try to do that too. Well, I guess I'll probably try to take it tomorrow as well. I have a tutor today, so we'll see. Maybe she'll help me, but I really feel lost in all of it. I got to get my notes more organized.
Yeah, I understand. Yeah, I'll do the class thing tonight and try to organize my notes while we're doing class.
Oh, we have class tonight?
Yeah, he's doing it tonight so that because the test is due Wednesday.
Oh, thank you for saying that. I'll come to that too then.
Yeah. And that always just kind of clarifies a little bit. Usually I'm like, well, I already know it, but I come and it just clarifies.
Yeah.
So
cool.
It's a good thing.
Well, cool. Thank you for videoing today.
We did it. Oh, yeah, I should go and stop that, huh? Stop the broadcast.